Hi, my name's Harshvardhan, and welcome to my course on Reason with BuckleScript. I'm a React developer and an author. In this course, we are going to learn what is Reason, why Reason, what is BuckleScript, and understand Reason and BuckleScript APIs. What is Reason? It is a toolchain powered by OCaml. It is not a new language in itself, but rather a syntactical sugar over OCaml. The new syntax has been designed in order to look familiar to JavaScript. Why reason? It is immutable by default. In fact, one has to explicitly state mutability in case it occurs. It has a very sound algebraic type system, and it can be compiled to different targets using BuckleScript for JavaScript and OCaml compiler to compile to native and bytecode. What is BuckleScript? BuckleScript is a compiler for Reason that emits highly optimized, readable JavaScript code. It maps Reason modules to JavaScript modules and is seamlessly interoperable with the JavaScript ecosystem, like allowing to call JavaScript functions straight from your Reason codebase. Now let's dive into the demo by installing the BuckleScript platform and creating a sample Reason boilerplate. First, we install BuckleScript platform globally using npm. Once we have installed the BuckleScript platform, all we need to do is create our sample application using the basic Reason theme, which can be done by psb init and then specifying the theme type. Here we are going to create an application named Reason app. And now we are ready to go. Now let us try to set up the editor before we begin with the development. Although there are numerous choices of editors available for Reason development, we're gonna use VS Code here since it's quite comprehensive. So we're gonna begin first with adding a Reason extension. Once it's installed, we're gonna do a quick reload. Once reloaded, we proceed to the user settings to make some configurational changes by adding Merlin and BSB among diagnostic tools and enabling CodeLens to see the types. It is also important to mention the OCaml Merlin path so that VS Code has access to the inferencing engine and provides a contextual analysis of the code base. Once done this, we can proceed to the Reason file and hover over code to see if the contextual analysis is working. Aha, now it's showing all the type analysis. Now, within the VS Code inbuilt terminal, we can do a npm run build and compile it to JavaScript. Click on the bs.js file to see the Java code base. Now we are ready to go with the development phase. So, what APIs will we be learning in this module? Well, in this module, we'll be learning certain set of APIs from Reason and certain set of APIs from BuckleScript. In Reason, we'll be learning let binding, an immutable way to assign values to variable, list and array, a mutable and immutable way to hold set of records, variant, assigning numerous possible options to a value. Now in BuckleScript, we'll be learning how to apply JavaScript functions to Reason data structures. And let's not forget existing JavaScript codebase is a thing, so we'll learn how to call JavaScript functions from our Reason codebase. Now it's time to understand some let binding. Let bindings are immutable by default. It can be redeclared, but it cannot be reassigned, because reassigning can lead to mutation of the state. They are accessible within the scope, be it scope of a module or be it scope of a if-else statement. List and array. List and array have few fundamental differences. List is immutable and it is declared using square brackets. It is fast for adding items at the beginning, whereas in case of array, it is mutable and is declared using square brackets and vertical bars. And it is fast for accessing random items. Other than that, array is very similar to lists. Variant. Variant allow us to define every possible type a value can be. And because of this nature, they allow us to write very exhaustive switch expressions, which allow us to cover every possible case. Here we are seeing an example of a variant. We have declared a variable status of type complete, in progress, and failed. And then we have assigned stage a value complete, one of the possible values of type status. Then we have passed the current status a value called stage declared above. After passing that value, now the switch statement will exhaustively search every possible type specified in the variant. Now we're gonna learn how to apply JavaScript functions on reason data structures and also call JavaScript functions of other files from reason. In this demo, first we are gonna begin with creating an array list. So let's create an array list called amount and let's fill it with value type integers. It is important to note down how we have used vertical bar, therefore it's an array list and not just a list. Now we're gonna create a variable called filtered list to hold a filtered amount from the amount array. Now we're gonna mention the amounts array. After this, we're gonna pass a pipe operator. Pipe operator acts as an applying function. Now JS dot allows us to call the JavaScript functions. So first we state the property, which is a type array, and then the function filter. In this case, we'll try to get a value greater than 2. Once we have done this, now we can test the value by doing js.log, which is a wraparound JavaScript's console.log. We can also check how BuckleScript wraps around the JavaScript functions by hovering over and clicking over them. And we can see external calls have been made and around every JavaScript property, be it array or boolean or date. Around every array properties, JavaScript functions have been wrapped around using OCaml. Now back to this, we can check in the terminal and run this piece of application to see if we can get the filtered amount. And that's 3, which is greater than 2 in this array set. Now let's try calling an external JavaScript function into a reason module. Here we have declared a JavaScript function that is add, which takes 2 parameters and returns the sum, and it has been exported using common.js. Now heading back to the reason file. First we'll mention the path of the JavaScript file. Once we have mentioned the path, we need to mention the external keyword. and then give a local name of the function, and then specifying the two variable types that have to be passed, followed by the return type, and then giving the name of the function itself in a string code. Once we have done this, now we can check the value using js.log and call the function. Let's pass value 2 and 3, and now check the value within the terminal. So now we have the value 5 called from external JavaScript file.